Welcome to geometry, a very exciting and interesting topic of mathematics. The word geometry is actually made up of two different words. Geo means earth, metry means measure. As you observe, most of the things that we see in our day-to-day life, right from our homes to very big dams and bridges, all of them are constructed using the principles of geometry. So geometry is the study of structures, shapes and sizes. Euclid, an ancient Greek mathematician, is called the father of geometry. Euclid wrote a collection of books called Elements. In his collection of books, Euclid has explained many different concepts of geometry. In his first book, Euclid has defined almost 23 different terms of geometry, and 7 out of those are listed here. Let's look at each one of them in detail. In mathematics, mathematicians have agreed to leave some words undefined, because if you kept on defining terms, you would be defining more and more terms to explain the concepts that were being described in the previous terms. So some of the basic terms have been left undefined to make the science easy. We have a general intuition of what a point is, right? But based on this definition, it is not really feasible to illustrate a point, because if I put a dot on the screen, it is still a shape with some dimension. This can be actually divided into millions and millions of smaller parts. So for simplicity, we have assumed that a dot is a point. So we'll assume that this dot cannot be broken into smaller parts, and so we call this a point. The next thing is a line is a breadthless length. Let's take an example. If you see, this is a rectangle. It has length and it has breadth. And what Euclid is saying is a line is a breadthless length. So if you take out the breadth, the remaining part is just the length, and this is a line. And this line can be extended infinitely on both directions. The ends of the line are points. That's the third definition that Euclid has given us. The fourth one states that a straight line is a line which lies evenly with the points on itself. Let's assume A and B are 2 points. What Euclid is saying is a straight line will lie evenly with the points on itself. So those 2 points would be on the line and the line would be even. So if we had something like this, if you observe, this is not an even line. So this is not a straight line. The next one says that a surface is that which has length and breadth only. So what he is saying is a figure like this is a surface because it has length and it has a breadth. And he also states that the edges of the surface are lines. As you see, there are 4 different lines that make up this surface. And finally, a plane surface is a surface which lies evenly with the straight lines on itself. So if you consider this, so this is a surface which lies evenly on all the 4 lines. If the surface was something like that, then it doesn't lie evenly with the straight lines on itself. These are not straight lines. It's not lying evenly on them. So these are the 7 definitions that Euclid has defined in his book of Elements. Euclid also gave the world some axioms. Axioms are statements which are assumed to be true. So these are like self-evident statements. So few of the axioms that he gave us are things which are equal to the same things are equal to one another. So this is something that is quite evident. Like if 2 things are equal to something else, then those 2 things must be equal to each other. If equals are added to equals, the wholes are equals. This is a repetition of the above, so let's take it out. The third thing, if equals are subtracted from equals, the remainders are also equal. Again, this is a self-evident statement. What it is saying is if A equal to B, C equal to D, A minus C is equal to B minus D. The next one is things which coincide with one another are also equal to one another. Again, it's a self-evident statement. The next one is things which are double of the same thing are equal to one another. So if you have two things and they're equal to the double of the same things, then these two things must be equal. The final one is like things which are half of the same things are equal to one another. So if A and B are equal to half x and half x, then A and B must be equal. So these are all the axioms that were given by Euclid. Next we will talk about Euclid's postulates. Postulates and axioms are used interchangeably in mathematics. The first postulate of Euclid states that to draw a straight line from point to any point. So what does Euclid mean by this? Take 2 points and then draw a straight line that passes through these 2 points. How many straight lines can you draw? You can draw only one and only one straight line through these 2 points. You cannot draw another straight line which connects these two dots. There is a unique line that passes through any two given distinct points. So that's the first postulate. The second one, Euclid states that to produce a finite straight line continuously in a straight line. So what does he mean by that? Draw a line segment PQ. And as you remember, the endpoints of the lines are points from the Euclid's definitions. So try to extend this line on both sides. How far can you expand this? Basically this can be extended infinitely and there are no endpoints. So what he means is any line segment can be expanded on either side of its ends continuously and infinitely, and a part of that straight line is called a line segment. The third postulate is to describe a circle with any center and distance. So if given a point and a distance, you can draw a circle with that distance as a radius. As you see here, we have drawn three different circles whose radius are three different measures. The fourth postulate that Euclid has given us is all right angles are equal to one another. So if you consider different types of right angles as seen here, in all these cases, let's assume that these are the angles A, B and C, all are right angles. So what Euclid is saying is, no matter how the orientation of the shape is, if there is a right angle between two different lines, then in all the cases the right angle will be equal. Next we will talk about Euclid's fifth postulate. This is a very important postulate out of all the five that Euclid has came up with. What it states is if a straight line is falling on two straight lines, makes interior angles on the same side less than two right angles, the straight lines, if produced infinitely, will meet on the side on which the angles are less than two right angles. Let's try to understand this. So consider the figure where you have two straight lines AB and CD. Now there is another straight line L which falls on AB and CD. And this line is making interior angles P and Q on the same side. If you observe, P and Q are less than two right angles. So what Euclid's postulate is stating is if these line segments AB and CD are extended infinitely, they are going to meet on the side at which the interior angles are less than two right angles. So in this case, AB and CD will meet some place on the left side of L if they are extended infinitely. Based on Euclid's fifth postulate, there are many other mathematicians who came up with equivalent versions of the fifth postulate. So the first among them was John Playfair, whose axiom states that through a point not on a given line, exactly one parallel line may be drawn to the given line. So what does he mean by that? Consider a line L and a point P which is not on the line L. Through P we can draw numerous lines, but there will be only one and only one line through P that will be parallel to L. So in this case, the line L dash, as you see here, is the only line that is parallel to L. So that's John Play's axiom. Another mathematician called Legendre came up with an axiom where he states the sum of the angles of any triangle is constant and is equal to two right angles. Consider three lines which intersect to form a triangle with angles 1, 2 and 3. The sum of all these three angles will be equal to two right angles, which is 180 degrees. Proclus came up with two other axioms which are as follows. If a straight line intersects any one of the two parallel lines, it will also intersect the other line. So consider two parallel lines P and Q. If there is a line L which is intersecting P, it will also intersect Q if you extend it. That's Proclus' first axiom. The second axiom states that straight lines parallel to the same straight line are also parallel to each other. So let's assume that a line P is parallel to Q. Also take another line R which is parallel to Q. So if P and R are parallel to Q, P and R are also parallel to each other. That is Proclus' second axiom. Posidominus also came up with an axiom which is equivalent to Euclid's fifth postulate. What Posidominus stated was, there exists a pair of lines everywhere which are equidistant from one another. So what Posidominus states that if there is a line segment L, then there is always a line segment M which is equidistant from L everywhere. Similarly, another set of lines P and Q, if there is a line segment P of this sort, you will always find one more line segment which is equidistant everywhere from it. That is, in this case, is Q.